Here we go. We just got through most of this, properties of logarithms, and I want to just go right back over it and talk about evaluation at the end, but I want to talk through all of these properties first. And here we go. And I want to be able to liken these properties of logarithms to their friends of exponents, okay? Because they're inverses of one another. And I need you to understand that these things end up looking the same way. Yeah, there's that word log with some weird base, and oh, it gets all scary. It's not that scary. Take your time, take a look at it, and you should be able to handle it. So we start off with the product property. And way back when you learned about x, is add those exponents together, 3 plus 4, and we have x to the 7th power. Well, it's the same thing here, only we expand this. Okay, so we're going to show that addition, right? Log, some log with base b to the xy of xy, there's multiplication here. Okay, well, how do we show that multiplication exists? Well, we're going to add those powers together. Here we go. So log base b of x plus log base b of y. And I'll show you when we start playing with this stuff over here. Now there's other stuff I have to throw in there too. Maybe I'll throw in a quick example to show you how easy it is. Let's talk about the quotient property. What happens when we have the same base and we're dividing with exponents? All right, well, 4 to the 6th power divided by 4 squared is 4 to the 6 minus 2, which is 4 to the 4th. Here, when we talk about logarithms, here it is, log base b x divided by y is the same thing as log base b of x minus log base b of y. And last but certainly not least, the power property. The power property is pretty cool because when you get to calculus, you're going to use that power property again and throw that power to the front when we start taking derivatives. You'll get used to it. Just remember that. Here we go. M to the 5th power, the whole thing to the power of 3, okay, we've raised that whole thing to the power of 3, is m to the 5 times 3, or m to the 15th. Here, we have a logarithm of base b of x to some power. We take that power, we throw it to the front, and we multiply, right? This letter in front of this log means multiply. There you go. Now, I want to do something real quick and show you how simple this can be. Show you one quick little logarithm here. Let's say, what if we have log base 3, 4 of 4x. Okay, this is multiplication, right? 4 times x. So all we're going to do is break them up with the same base, just like it says over there. And I'm going to rewrite this as log base 3, 4 plus log base 3 of x. That's it. It doesn't get any simpler, any more difficult than that, unless, of course, there's a power, right? So just for fun, I'm going to leave it just like this. Here's our 4x, but I'm going to say it's 4x to the 3rd. Nah, we'll make it 4x to the 5th. I don't want you to confuse the base, the log base there. Let's do that. This is the same thing. This is an entity unto itself, and this whole thing is an entity unto itself. So we're going to do it again. Log base 3 of 4 plus log base 3 of x to the 5th. Now, what can I do with that power? What does that power property say? It says take this sucker right here, pardon my language, and throw it right up front. Okay, and then we'll rewrite it. Same as always, log base 3 of 4 plus 5 times log base 3 of x. And that's it. That's as expanded as it can go from here. All right? The same thing holds true with division. And what I'm going to do, just make a tiny little change here. And we'll use 4, and we'll use x to the 5th again. We'll say 4 divided by x to the 5th. Why not? So we're going to keep the same base. That's our little base there. Log base 3 of 4. But instead of adding, we have division, so we'll subtract log base 3 of x to the 5th. Again, here's our power, throw it up front. Log base 3 of 4 minus 5 log base 3 of x. That's as expanded as we can make it. All right, now we're going to put it all together. Right, all together, but we have to do one tiny thing first. Are you nervous? Don't be nervous. You did this in class, so you should be able to remember this. I know I have a goal. I have a goal. My goal is to create somewhere in here so that I can cancel a log with the same base and the same argument. Because that means it has an exponent of 1. Doesn't that make sense? If I say 3 to the what power is 3, right, my argument, and my base, what's the exponent? Well, x would have to be 1. Okay, so that's what I'm trying to create. That's what I'm trying to show. That way I can basically cancel it out. Here, I have evaluate this one. 3 times log base 2 of 8 plus 5 times log base 2 of a half. So I have 2 terms here. I have 2 arguments here that need to be rewritten as some power of 2. Some 2 to some power. Well, I know how to do this one. Right? Everybody knows that 8 is 2 cubed. 2 cubed. And then we'll write in our log base 2 and our 3. We'll still add, you've got 5 log 2. Now this one here, some of you don't remember your negative exponents, right? Because anything, x to the negative 1 is the same thing as 1 over x. X to the negative 4 is the same thing as 1 over x to the 4th. That's a really bad x. Sorry about that. Now I'll erase that and we'll move on. Hopefully you saw. Oh, you did see it. Yay. Okay. Here we go. I'm back in the frame. Now I can use my power rule and cancel. I take this power, I throw it up front, I rewrite 3 times 3, that's the power 3, times 3, log base 2 of 2. Well, remember, log base b of b equals 1. These two things cancel out and equal 1. Cool? Let's continue. I take this power, I throw it up front. Negative 1 times 5 log, oh, that's horrible. Log base 2 of 2. These two things, just like that, the same, they equal 1. So let's do our math. 3 times 3 times 1 plus negative 1 times 5 times 1. This is 9. This is negative 5. The answer is 4. Pretty good. That's an evaluation because we were able to cancel out our logs. We can't come up with a number unless we are able to cancel out our logs. If we can't do it, then we're going to do something completely different. And that'll be the next video. All right, let's take a look at this one. What do I want? I want some power of 3 because my log base is 3, okay? And I want it with these two arguments. This one and this one. This one we know. They like cubes for some reason. So it's 2 times log base 3, and it's 3 to the third power, right? 3 to the third is 27. Now 4 log base 3. And this is, remember I showed you over here, the -1. This is 3 to the -1. That's 1/3, right? All right, well, what did I do over here? I took my powers and I threw them up front and I rewrote. And I was able to cancel. So, throw it up front. 3 times 2. Log base 3 of 3 cancels, gives me a 1. Plus 4. Ah, what did I forget? -1 times 4. Log base 3 of 3 cancels, gives me a 1. So I have 3 times 2 times 1 plus -1 times 4 times 1. So it's 6 plus -4, which gives me 2. And that's evaluation. That was the big, big, big part of what we did yesterday and repeated today. Don't forget that goal. We love this. We love the same base and the same argument. Why? Because the only way to get that base with that argument is to have an exponent of 1. All right, so thank you for your time. Don't forget any of this stuff. I wrote a lot of stuff down here. I also need you to remember for next time, the last little hint that I'm going to give you for next time. We did negative exponents. Don't forget, when you have a fractional exponent, write this down. You probably have it written down, and I'm going to leave it up for the next one. That the numerator is the power, and the denominator is the root. X to the 2/3 power is cube root of x squared. That was a lot to get out of my mouth, apparently. There you go. That's about it. Thank you for your time. I hope that you were able to hear me. I was yelling a lot. Thanks so much. Bye-bye.